Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate the percent yield of a chemical reaction. So let's jump right in and take a look at an example problem. In this example problem, it says that we have 117 grams of phosphorus reacting with excess bromine according to the reaction equation shown below. After a scientist performs the chemical reaction, they find the actual yield of phosphorus tribromide to be 714 grams. Calculate the percent yield of this chemical reaction. So we have a chemical reaction right here where we have phosphorus reacting with bromine to produce phosphorus tribromide. And so if we read this question here, it tells us that we have 117 grams of this stuff right here of phosphorus reacting. So we have 117 grams of phosphorus reacting with excess bromine. What we're asked to determine is the percent yield of this chemical reaction. We also know that the scientists performed this experiment or this chemical reaction in the laboratory, and they figured out that 714 grams of this stuff right here was formed. So how can we calculate the percent yield? Well, in an earlier video we talked a little bit about percent yield, and we said that percent yield is a comparison between two things. Percent yield is a comparison between something called the actual yield, which is the amount of product that is formed during an actual chemical reaction that takes place in the laboratory, and something called the theoretical yield. That is the amount of product that is formed through the mathematical process called stoichiometry. And so we can get the percent yield by taking the actual yield, dividing it by the theoretical yield, and multiplying by 100. So if we take a look at this problem here, we have some given information. If we take a look, it says after a scientist performs the chemical reaction, they find the actual yield of phosphorus tribromide to be 714 grams. So we know that the actual yield, which we'll label here as AY for actual yield, is 714 grams. If we read the question, it says the scientists performed the chemical reaction. They did this in the lab, and they found that the amount of phosphorus tribromide that was produced was 714 grams. So here's our actual yield, and we will put that here in our formula. So how do we get the theoretical yield so that way we can calculate the percent yield? Well, we're going to have to do some stoichiometry first to figure out the theoretical yield. Once we do that, we can plug the actual yield into here, our theoretical yield into here, and then we can determine the percent yield. So let's go ahead and rewrite this chemical reaction equation. In this chemical reaction equation, we have phosphorus reacting with bromine here. And this is going to end up producing phosphorus tribromide. So the very first thing that we have to do before we can calculate the theoretical yield is we have to balance the chemical equation. So let's go ahead and do that. Looks like we're going to need well, we have 4 phosphorus here. So we're going to have to put a 4 in front of here. That now gives us 4 phosphorus. 4 times 3 is 12 bromines on the right. So we're going to need 12 bromines on the left. 6 times 2 is 12 bromines. So our chemical equation is now balanced. So in this problem here, it tells us that we have 117 grams of phosphorus. So we have 117 grams of this stuff right here. We need to calculate the theoretical yield of phosphorus tribromide. So we have 117 grams of phosphorus, and now we just need to do the stoichiometry here that we learned how to do in an earlier video to determine the mass or theoretical yield of PBr3. So we want to cancel out grams of phosphorus, so we'll put that at the bottom of this little fraction here. And we're going to first convert to moles of phosphorus. We'll put that at the top. Once we're done doing that, we're going to cancel out moles of phosphorus. So we'll put that at the bottom of this fraction. And we're going to figure out moles of PBr3. So we'll put that at the top. We're then going to cancel out moles of PBr3 and figure out the number of grams of PBr3. And so now, what's going to go in these empty spaces right here? Well, we have to figure out the molar mass of P4. So if we take a look on our periodic table of elements, like the one that just popped up, we can see that the molar mass of one phosphorus is 30.97. So if we have P4, we'll figure out the molar mass right here of P4. P4 is made up of 4 phosphorus atoms. One phosphorus atom has a molar mass of 30.97. So when we take 4 times 30.97, we're going to end up with 123.88 grams per mole. So 1 mole of P4 we just figured out is 123.88. What about our mole ratio? What is our mole ratio? Well, we see we have 4 moles of phosphorus tribromide for every 1 mole of phosphorus. And then right here we have to figure out the molar mass of PBr3. So let's do that right here. If we have PBr3, we can see that this compound is made up of phosphorus and bromine. There's 1 phosphorus, there's 3 bromines. So let's figure out the molar mass of this. 1 times the molar mass of phosphorus, which is 30.97. And then we have 3 times our molar mass of bromine, which if we take a look on that periodic table of elements is 79.90. And this is going to give us 239.7 or 239.70. And when we add these together, we're going to end up with 270.67 grams per mole. So we know 1 mole of PBr3 is 270.67 grams of PBr3. So we start from the left here with 117, the starting quantity. We'll divide by 123.88. We'll multiply by 4. We'll multiply by 270.67. And we're going to end up with a theoretical yield of, let's do this one more time, 117 divided by 123.88 times 4 times 270.67, 1022.6 approximately. If we use the correct number of sig figs here, it looks like this is going to end up being, let me erase this right here so we can fit this in. If we use scientific notation, we're going to end up with 1.02 times 10 to the third grams of PBr3. And this is not our final answer. This right here is just our theoretical yield. So we just figured out the theoretical yield. Theoretically, if we have 117 grams of this reacting with an excess amount of bromine, how many grams of phosphorus tribromide should be produced? 1.02 times 10 to the third grams. And this right here is going to be our theoretical yield. So now, how can we figure out our percent yield? Well, to get our percent yield, we're going to take the actual yield. What did we get in the experiment? Well, if we take a look, the actual yield is 714 grams. We're going to divide this by the theoretical yield we just figured out is right here, 1.02 times 10 to the third grams. and then we're going to multiply by 100. So when we take 714 divided by 1.02 times 10 to the third, and then multiply by 100, we're going to end up with 70%, or 70.0% as our final answer. So we'll go ahead and highlight this in red, or box this in red as our final answer. The percent yield here is equal to 70.0%. So what does this mean? Well, if we take a look at what this means, is theoretically we should have ended up with 1.02 times 10 to the third grams, or the scientists should have ended up with this many grams of phosphorus tribromide, but instead when they were in the lab they ended up with 714 grams of it, which represents 70.0% of what the true value or theoretical yield should have been. So that's how we can calculate a percent yield. If you like what you see, go ahead and click that little bomb on the bottom right hand corner, and that will subscribe to my channel. And feel free to leave any comments or questions in the comment section down below, and I really hope you guys found this helpful.